So the first thing you do is you make your standard solution, you grab your chemical and you are going to weigh it. So I'm using sodium hydroxide here. You can see the purities there. And I'm using a Mettler balance over there. So the first thing I do is I tear the balance so it's all zeros. And so that's the first error, plus or minus 0.001. I think it's, and then, so I'm going to tear it. There we go. And then the second error will be putting the weight on there, which will be another 0.001. So the error will be 0.02. I'll do the calculations at the end. And so this one here, you'll see that the sodium hydroxide pellets start to get a little bit wet as soon as you take them out. They're hygroscopic. And so that's an error that will occur that you need to be aware of. So not the best material to use for a standard. Okay, and if I can pause it in the right spot, you'll see it's a little bit shiny down there. It's starting to absorb water. So the next thing you do is you flush, make sure you've flushed out all of the particles out of the weighing boat, and then also flush all around the funnel as well. So every single little particle goes inside. Now, once you've got a little bit of water in there, then make sure you've fully dissolved it. So mix that around before you fill it up to the meniscus. So there we go, I'm mixing it around. And once it's fully dissolved, then you can fill it up to the meniscus. So I'll just go to there. There we go, adding the drops. Almost there, maybe one more. Maybe one more. Okay, that's about it. All right, that's spot on. Now, make sure it's on the bench and you're looking parallel to it. If I'm looking from underneath, it's going to look like that. And so it's going to look like you haven't put enough in there. All right, and so I'll try and find one where I'm looking too high, and that's too high. Okay, so that's definitely looking from above. And then you can see from the way the camera moved, and it looks like I've added too much. Okay, so make sure it's parallel. And so the last thing you need to do is mix it. So do quarter turn, invert, quarter turn, invert, quarter turn, invert. Do that 20 times. And you're done. You've made your standard solution. Just go into the calculations now. So this is a 3-part series. So what I've done is I've actually done 2 standard solutions. And then I'm aliquoting and then I'm trying to work out what the concentration of HCl is, 25 mils of it. And so what I've done here is I've tried to make a 0.5 molar. So I've tried to work out how am I going to do that. I'm going to need 0.125 moles, and 0.125 moles is about 5 grams of sodium hydroxide. So that's just some rough calculations. So from that experiment you just saw, I grabbed about 5, so it was 5.3. So these are the calculations you need to do here for a standard solution. And that works out to this 0.13 moles, and that's dissolved in a 250 ml volumetric flask. So that this concentration is going to be 0.533. Now your errors will be double the 0.01 for the balance, and that's now going to be a times and divide calculation. So I have to turn that to a percentage. So divide that by the mass, it's a 0.038%. And then the flask itself has a really tiny error, which is 0.06%. And so the total error will be these 2 percentage errors added together. So the error for this constant standard solution concentration is close to 0.1%. Okay, and then I've just repeated those calculations for a different one. And so that's how you are to do the calculations, and that's how you to do the uncertainty.